Once again, a bit more jargon with probability. Independent events. We've talked about mutually exclusive events, and now we're going to talk about independent events. They're quite different. So independent events can be defined as the chance of one event occurring is not altered by others. So you've got two different events, and what happens in B, if A is done first and then B is done second, what happens in, say, A, then if A happens first, what happens there does not affect what happens in B. So they are called independent events. One does not affect the other. So if these two events, so if you've got two events A and B, the probability of both of them happening, if they are independent, we associate AND with multiply. Don't forget from previous lectures, OR is add. So A and B, probability of A times the probability of B, if they are independent events. Now, if you toss a coin 5 times, and say you've got 4 heads in the first, then the 5th toss, it's still probability of a head is still equal to a half. It doesn't matter if you've got 4 heads straight up and you're tossing it 5 times. The 5th toss, the probability of head is still going to be a half, because these are independent events. Each toss is an independent event. Doesn't matter what's happened before. The 5th toss will still be a probability of a half that you're going to get a head. Alright, so let's just look at independent and non-independent events by way of an example. And say we have a box, and that box has 3 yellow marbles, and it has 4 blue ones. So we have 7 marbles all up, so we've got 3 blue and we've got 3 yellow. So we're going to draw 2 marbles, one at a time. And what's the probability you get 2 blue with replacement? In other words, you draw the first one, and then you put it back in again, and you draw the second one. So probability of 2 blue is equal to the probability you get a blue on the first draw times the probability you get a blue on the second draw. Bearing in mind that you're going to put whatever you draw out first, you're going to put it back in again. So we'll use our multiplication principle up here for independent events. Probability of a blue. How many blues were there? There were 4. How many total were in there? 7. Times probability of a blue, given that you put the first blue back in again, is also 4 over 7, which is equal to 16 on 49. So this is an example of independent events. The 2 draws are independent of each other because you're putting the marble or whatever back in after you've drawn the first one out. Okay, now this brings us on to a rule for conditional probability. I'm going to come back to this example. Conditional probability involves events that are not independent, in other words they are dependent. So if A and B are dependent, we've got an E in there somewhere. So if A and B are dependent events, the rule states that probability of A and B equals a probability of A times, now up here we had the rule for if they are independent. If they are dependent, it's going to be slightly different. It's the probability of A, same as above, but it's times now the probability of B given that A has occurred, and that's the way we write that. We're saying, okay, given that A has occurred, first up, calculate a new probability for B and multiply these two together. So this is for dependent event. Okay, if you turn these two around, you've got the probability of B and A both occurring equals probability, it's always this one goes first, probability of B times, and then it's the probability of A given B. Okay, just another way of writing it there. So we go back to our example up here where we've got our 3 yellows and 4 blues, marbles or balls that are in a box here. And we're going to draw out 2 marbles one at a time, but this time we are not going to put the first one back, and that will change things. So what's the probability of 2 blues if no replacement? So that's going to change it because it'll depend on what happens with the first one. So the probability, first blue, and the second being blue. First blue and the second blue will be equal to probability you get a blue first times the probability you get a blue second, given that you've got a blue first. Okay, what's the probability you get a blue first? You've got 7 in there and there are 4 blues, so that will be 4 over 7 times. Now you haven't put the first one back in. Now you've got a blue first. So there were 7 in there, we've got a blue first. I've got one of those that's been taken out. How many are left in there? There are 6 left. How many blues are left? 3 blues are left. So the probability you're going to get a blue second, given that the blue has been drawn out first, will be 3 blues left. How many left in there? 6. And I think you'll get some cancelling going on here. And we get 2 chances in 7. Okay, so that's conditional probability. Conditional probability when 2 or more events happen that are dependent. And so in other words, that the second one occurring will change depending on what happens with the first event happening. So we have to use the probability of A and B equals probability of A multiplied by the probability of B given that A has already occurred. And we write a probability of B slash A. It can be rearranged there, and we've just worked through an example there.